Okay. My time with you is almost over now, because we're moving to the bit where you can just carry on and do this stuff yourself. So you can do it very quickly, but you can do it yourself and work through it. This is deriving measures of variability appropriate to data. So we've recognised that it's critical to actually make a measure of variability. We can't make a true measurement. So what we can do is make a measurement and an indication of its reliability. And I suppose another one of these things when people say, well, how, what's a scientist? And a scientist is somebody that won't just give you one number. They give you the measurement and a measure of its variability. And you can understand why that is the case, because you can't make a true measurement. So you have to say, here's my measurement, and here's my measure of its variability. And say, all the way through this course, and largely your professional life, will be about that. It will be, here's an answer, and here's my qualification of the answer. Okay? This is the fundamental, the atomic part of that, right? Which is just a single measurement. And with a single measurement, even, here's my single measurement, and here's the qualification that goes with it. But you should recognise that really your professional life as a scientist is about doing that, in not just at the atomic scale, but across the project, across, what's the answer to the question, how many people are going to die from cancer due to a radionuclide release from Sellafield. Here's the number, and here's like a 300-page report on why that number might be good or bad. That's typically what your work will be. And this is, like I say, just the atomic part of that. So it's useful for us to be able to quantify the likelihood of the coincidence of sample mean to population mean. So what's the likelihood of our sample mean, which is those measurements we made, coinciding with the true measurement? The true measurement is the mean of all the possible measurements. And we need to be able to say something about the likelihood of that. The following sections allow you to derive different measures of variability, recognise their various advantages and disadvantages. I know before you start that you all know what the standard deviation is. What we're doing to start with here, though, is working towards defining the standard deviation. Okay, you may have even done this before, but most likely you just use the standard deviation. I want you to understand why you use it. And, one of the exercises towards the end of this is to just write a one-page essay saying why is standard deviation the most commonly used measure of variability. Okay. If you think that you're all right with this already, you could write that essay right now and have a go at it and see where you get to. But if you follow this argument through step by step, and you should be able to answer that. Okay. That's where this is going. So in order to do that, we need to have a set of data that's variable. You might be sitting there feeling a bit glum at this point, but you would be glummer if you were the people that had 1 year. It was actually quite a while ago now, but we actually did collect the data, which is the heights of students coming in the building. It just was the easiest thing to do, and it was really at the time. And measure the heights of students coming into this building. So 500 students, the first 500 students that came in, measured their height. So that's the data set that we've got. Exercise that we'll do is to download the spreadsheet and draw the graphs, just draw the cumulative frequency graphs. Now again, if you're used to doing that, that's fine, but if you're not, there's a little bit of training in using Excel and certain functions in Excel, which you may know already anyway, and you can just do that. So you'll end up with these different distributions, and then you can answer the question which is there for you about it. In which year was the sample mean more likely to be equal to the population mean, and why? So it's always two graphs, and you can make that decision. And it's just, these are the two distributions that you'll end up with. You've got the one on the left and the one on the right. Which one of those two is the sample mean more likely to coincide with the population mean? If you think it's the one on the left, put your hand up. If you think it's the one on the right, put your hand up. Try one more time. If you think it's the one on the right, and remember, you need to put your hand up for something. If you think it's the one on the right, put your hand up. Okay. Well, why is it the one on the right? It is the one on the right. Okay. Yeah. The variation, it's smaller, isn't it? It's a narrower distribution. So if you were to sample from that narrower distribution, it's more likely that you're going to get the same, you're going to get the true mean. The reason why I put this blackboard as an exercise for you to do is so you can do it and you can think it through, and it's better than me just talking about it. But one way of thinking about this was, imagine if we were at the University of the Future and we measured the students coming in, and they were all Series 5000 robots, right? So they're all exactly 1.6 meters high. So if they're all 1.6 meters high, the distribution would just look like this, wouldn't it? There'd just be a spike at 1.6 meters. And if everyone was a robot at 1.6 meters high, then whatever sample you take of that population, it's very likely that it's going to match the true mean. Okay, so that's the robot explanation for this, which you can see by yourself anyway. So, I'm going to turn this over to you guys, really. Data set which you can download, student height data. That spreadsheet's got various tabs in it, various exercises we can be doing with that. If you download it, there's two videos there of how to do the frequency distribution and how to do the other things that are involved really. But what you're doing is, so you know, you're working towards defining the standard deviation. I'm going to let you do it, but let me not just to repeat what's on there, but just to let you know what's going to go on with the doing it. You've got the data. First of all, you do the cumulative frequency distributions, and by looking at them, you can see which population is more likely to generate a sample that is representative of the true mean. So we're going some way towards having something useful there, but ultimately what we need is something that's comparable between all populations, and instead of something that we look at, we need to have a number so we can compare it. So you need to work towards a number that's a measure of variability. What you've got at the moment is that you can look at a frequency distribution and tell from that which is more variable. So we need to come up with a measure of variability that's a number. I'm trying to make you regress, really. I'm trying to get you forget what you know already, and let's derive standard deviation from first principles. And if you were to derive a measure of variability from first principles, well, there's probably someone here who's ludicrously, smarter than me anyway, smarter than me, and this might not apply, but your first thought would be, as a measure of variability, well, what some people use even is the range of the data. So that is a measure of the variability. It's a poor measure though, because it only uses 2 of the data points. So if you've got a whole data set and you use 2 of them, it's not a good measure of variability. The next step was, well, come up with your own measure of variability, and I'm prompting you a bit here, and it will do the same thing on the video. If you were to do that, you'd think, well, I can measure the mean, and then if I want to use all the data points, well, let's use them all. So let's look at the difference between the mean and every data point. If we take the difference between the mean and every data point and add them all together, if the number's very big, it means it's very variable. If it's small, it means it's not. So a little light flashing, first of all, saying, hang on a minute, if you add the differences together, they'll actually sum to 0. The positive difference and the negative will sum to 0. But if we take account of that, so if we disregard the sign of the differences and add them together, then if we've got a population that's very variable, then a large number, when we add the difference between the mean and every one in the sample, every one of the data points, a large number would mean it's a very variable population, and a small number would mean it's not. Okay? That sounds pretty good. But then we need to compare one population to another. The populations might be different sizes. How do we cope with that? Well, we could divide our number by the size of the population. So we could standardize our measure of variability by dividing it. And logically, from first principles, that seems the way you should go for measuring variability. Do the video and it'll say it all again. But that's what we've come up with. I mean, really, that's what I would come up with. There's another jump that takes us to standard deviation, and I want you to see the difference between that measure of variability that you come up with. Someone here might come up with standard deviation, but generally that's what we've come up with. But there's a jump between that and standard deviation, and recognising how you go from there to standard deviation is really important in recognising how to use it properly and what it really means. So I think that the best thing really now for me is to just let you get on with it. You know, you've got from now until next Wednesday. So just work through these. You can work through this, you can do as much of it as you like. But the things that you need to get done really are the you've been through this, deriving measures of variability, so go through that spreadsheet, and then you can look at recognise that random variability can be modelled. Make sure you've looked at it and do what you can on it, okay? But don't worry if you haven't. If you have any problem with it, don't worry, because we'll talk about that in class. Okay? Some of you will just go through that, it's fine. But try and make sure you've done all this. And, you know, try and do this as well, but if there's any problems with it, you don't need to email me or ask me. We'll go through it in class, just have a play with it, and see where you get to. But in that section, we start to get some of the links through to environmental processes as well. And there's a conceptual jump in there that's important. So if you can do those, and so don't worry, we'll go through anything that you've got a problem with. So you can spend time now and time between now and next Wednesday. Okay. Right. I think that's it really. Does anyone? No. Thank you very much. So, see you. Has everyone sorted out with their elective modules, their choice? Have you all selected something? Have you?
Some of them see which one you like, so we can check out the information.
Yeah.
Everything now we cannot drop courses. It says that you won't have enough credits for the semester or something like that.
If you see Carol, if you've got a problem, she'll sort that out.
I mailed her.
Okay. Yeah, it's fine. That's okay. As long as you... Yeah, as long as you... How many of you are doing Colin Hughes' course? The environmental consultancy course? Who's doing that? Yeah, Anybody else? You doing it as well? You might. Okay. Well, who's considering doing it? Okay. We're going to be covering, like, a lot of these things do link together. Like I say, there's links between this and the tutorial module. Within this module, there's a lot of things that link together. Like I say, my stuff's going to link to Neil's and to Paul's. We're going to be going through some contaminated land sort of training sort of stuff, really, about background legislation things as well, in this course, which relate to what John Lloyd's going to be doing with you as well. So I suppose what I'm saying is you try and make connections between your courses. I know you're not all doing the same elective module, but there should be connections between them, and it's a big difference really between what you might do as an undergraduate and what you're doing in the MSc. We'd like the undergraduates to make connections between the courses, but in the end they generally don't, and they're not really assessed on that. But you should try and see the similar things going on. If you can take something that you've learnt in one course and apply it in another, or something you've learnt in one part of this course and apply it in another part of it, then that would mean that things were quite successful. So try and do it. Okay. So you all got your tutorials as well. You all got types of the actual tutorials. You all know what you're doing. Back on. Kath Morris's, because someone was away for. It's Kath Morris's tutor he's talked about. Not very possible. Who's got their tutors? Kath Morris, Professor Morris. You know what kind of tutorial is? Okay. All right. Thank you. I'll put the recording of the lecture onto the Blackboard site. Unfortunately, I'm not going to have time to edit it, so it's just the whole unedited thing. But you can listen to it. You can fast forward it.